Hello, this is Clint Halstead, and this is a continuation of a lesson series, internet series, called the Introduction to Microprocessors. We're using the textbook called Design Embedded Systems with PIC Microcontrollers, Principles and Applications with second edition with Tim Wilmshurst. And we're using the ping pong project. We've been working on this project. In the previous lesson, the students built this project using the PIC16 lab development kit by Microchip. It's a part number DM163045. And what we did was we built the hardware, we verified the power, we downloaded the code from the website above, we created a project in MPLABX, added the assembly code and header file information for the configuration word, then we compiled it, downloaded it, and ran it on the chip. And so this was like a little ping pong project where the LEDs go back and forth. But now we want to, the PIC16 lab development board from Microchip allows us to solderlessly build this kit, but it's a little messy and it's not permanent. You know, it's just a temporary solution. So now we want to build a permanent board that we can always have with us. It's going to teach us how to do the actual hardware component of microprocessors. And this is the part where a lot of maybe instructors will omit this section of microprocessors, but I feel it's very important. I feel it's just as equally important to know how to do the software and to know how to use the tools than it is to actually build the hardware. So we're actually going to take this week, this time in this lesson to work on learning how to build some hardware. So my suggestion, what we're going to use in this lesson is CAD software, because it's free. It's free for students. You can even buy a hobby version of it. It's a nice software. You can do I think a 3x4 size board, 2 layers. So what I'm asking is for you to go ahead and download the free CAD software. We can use this link, or you can just Google CAD software, Google that. And then you can watch the CAD tutorials. This is how I learned how to use Eagle. A guy named Jason Roush from NASA, currently works at NASA. He made these videos. He did a really good job. So these are on the CADsoft website. If you go to training and then third-party lessons, where you can click the link and watch all 11 videos. They're really great videos. Go through it and learn how to use the tutorial. Make sure that you're very familiar with how to use it. Also, I would suggest to watch the videos. There's also some videos on the CAD website. There are YouTube videos as well. And learn how to make libraries, so how to edit libraries and how to make a library, because many times the components you want are not in the library, and so you have to be able to add your own library components. So go ahead and watch those 2 videos, and then once you watch all the videos and feel pretty good with the software, then go ahead and open the CAD software and go to Open, Projects, Examples, Single-Sided, which we're going to do that right now. I'll do that in just a second. We're going to modify the example to match your ping pong hardware. I want you to be sure to add a program header so you can plug in your PIC-3. Decide on how you want to power the board. You want to use your adapter with the linear regulator, which is inside the example CAD, or do you want to add 3 AA batteries or AAA batteries or whatever, or do you want to add a 9 volt? So you have to make a decision on how you want to power the board. If you use something other than 4.5 or 5 volts, then you have to have a linear regulator to drop down that voltage. And then I want you to take a video of your final ping pong project working with your advanced code that you wrote to make the LEDs start off slow and then go faster. And I also want to see your handmade CAD PCB board. So let's go look at how we do this open projects examples. So you go to the website and you download Eagle software. The latest version is 6.2. So if we open 6.2, looks like we get a board already popped up, but typically that doesn't happen. I think I had that open last time. So we go to File, Open, Project, and then there's some examples. There's 3 examples. So we want to do the single-sided. File, Open, Project, Examples, single-sided. Okay. So we have the files here. We have a board and we have a schematic. So let's open the board. Let's open the schematic. Now in Eagle, if you don't have the board and the schematic open at the same time, then your files can get out of sync. They can get to where they no longer match, because your schematic and your board are always supposed to match. They're always supposed to, every time you add a component on your schematic, it's supposed to show up on your board. And you can see here, so always have the 2 open at the same time. So here you can see that the actual design here is actually a PIC84 chip, which is the same chip that we're using. So that's why I like to use this one as an example. So you can edit this. You have a linear regulator here that takes a 12 volts, it drops it down to a 5 volts, and then that connects over here to your 16F84, and you have a external crystal oscillator, which in our example we're going to be using the RC oscillator, so go ahead and make that change. And then you're going to add your program header and all that good stuff, just like we have here on the PowerPoint slides. So that's pretty much how you do that. Also wanted to, and then this is, you can see if you close the schematic before the board, then you get this message that says feedback annotation has been severed. So what it's trying to tell you is don't do that. You don't need to ever close, you don't want to close the schematic and then start working on the board. But you can see here that, so let's go over there and open the board back up. Let's open the schematic back up again. So as soon as you open the schematic, that error message goes away. So just an example, if you want to auto route this board, just click auto. If you want to do double-sided, it quickly auto routes the board. Okay, so that's the first step, is modifying the schematic to match your ping pong project. Okay. So after we do that, I wanted to show, let's see here, these are the prototyping supplies that I'm using in the lab. So I had a mini drill. I don't really recommend this drill. I didn't really like this drill that much. I prefer like a professional bench press type drill that maybe you get from Home Depot or something like that. But if you can't afford that, then go ahead and get this mini drill kit. It'll work. It'll get the job done. But something a little bit more substantial would be better. Maybe even a Dremel kit or something. You want to have an ultraviolet exposure frame. So this is going to cost about $1,000 if you want to get into PCB design, unless you want to make your own equipment, which you can. You definitely have to have the etching and the liquid ferric chloride. These are the 2 main chemicals you need. Well, this is the processing kit. The chemical here is you got the positive developer, that's cheap, and then you got the ferric chloride. Those are the 2 chemicals. This etching process kit, this is what you put the ferric chloride inside of. It's just a kind of like a little fish tank thing that you can put your board in. Yeah, I would recommend the ultraviolet frame, etching process kit, ferric chloride, and the positive developer. And of course you have to have, you can get any old transparency films. You don't have to get, these are kind of expensive, but you can get them if you want. And then you need the pre-sensitized positive PCB boards, single-sided or double-sided, depending on whatever you want to do. And the rest of the things on here, of course you need the positive developer, like I said, the flux remover, liquid rosin, safety gloves. I recommend the safety gloves and the apron just so you don't get your clothes dirty, because if this ferric chloride stuff is nasty stuff, you need to have gloves and eye goggles. You don't want to be messing around with these chemicals. get them on your skin or anything. It'll start burning you. Tip tinner, all this stuff is just good stuff to have for when you go to solder your board. You also need to have a good soldering iron, like a Weller or something like that. So next thing you need to do after you have all your supplies, you have your design done in EagleCAD, then you need to print out your design on a transparency. So I'll show you how to quickly do that. Once you got your board design done, you just simply go to File, and then Print. That's all you got to do. Make sure your scale factor is 1. If you want to blow it up just to look at it, then you can blow it up, but then make sure it's on 1, because all your scales need to be right. It needs to be the right scale size. And then the default is it's going to come in. It's going to come in a color. You want to make it black. So click the black button. Set the scale to 1. And then you want to put your transparency into your printer and then just say print. So just say OK down here and it'll print it. Okay? So once you do that, you'll have a transparency with your design on it. Now this design has a couple of air wires because I just did a double-sided board. I didn't really finish. I just did this board really quick just to show the concept. So you need to make sure you don't have any air wires. So you click print your transparency. So once you got your transparency, then you can take your UV light, which is the part number I showed you in the supplies kit. Then you can. This is the $700 piece of equipment from Electronics Express. It's really nice. You take your board, which this one's already been actually exposed and developed, but typically this board is going to be just all green. It's going to have a white film on one side, black on the other side. You peel the film back, and it's going to be all green. You lay your transparency on top of this, and then you expose this for about 40 to 50 seconds. You make sure that the light button is the correct light. Play around with your buttons before you do this and make sure you turn the correct light on. I've had a lot of students turn the bottom light on when they thought that they were trying to turn the top light on. And I had a student do that like 5 or 6 times and never could figure out what was wrong, and that was what was wrong. So make sure you turn the correct, because this is designed for a double-sided board. And then after you do that, you take it out. It's still going to look almost all green. You can tell a slight discoloration where the traces are at. But then you're going to want to have the developer solution, again from Electronics Express, made by MG Chemicals manufacturer. So then you want to take that board. Initially it's all green. You put it in the solution. You have to dilute this with water, and then you kind of leave it in there, swish it around a little bit. You'll see that the green starts to eat away, and you just have to time it. You have to watch it. You can't just walk away. And if it's going too slow, it should only take like maybe 5 or 10 minutes. If it's too slow, then you can add more developer. If it's too fast, you need to add more water. You may destroy your board the first time. You kind of have to. It's kind of like an art, more of an art than a science to this. And here's the information on the part number here for this developer, and the instructions there. And then what you're going to want to do after you get to this level, after your board looks like this, when you get done with the developing process, then you're going to want to put the ferric chloride inside of this. You want to buy this part number. I think this is let's see, how much was this one? This one was etching process kit, $165. That's well worth it right there. You may want to build your own UV frame or not, but definitely the etching process kit's a nice thing to have. Put your board in here. You want to, before you put it in here, you want to make sure that you have your heater on for an hour. This stuff works. This solution works a lot better. The ferric chloride works a lot better when it's warm. So turn on an hour before, then put it in here. It's got a little frame where you can lower it down. Put it in the solution, then turn on the pump. Leave it in for about 30 minutes, then check it. You may want to rotate your board through this process too. Sometimes you get an uneven on one side of the board. It's not etching, the other side it is. So just watch it close. Wear gloves. Wear goggles. Wear a smock. Wear everything. You don't want to get this solution on you. And don't overexpose, your traces will be gone. Then after you do that, then you're going to have a board that looks similar to the one in this diagram that has just the copper and the board material. And then you're going to have to drill your holes. A lot of times I make these larger than what it is because a lot of times there's uneven etching. And it usually does it on the edges, but usually in the middle it does pretty good, so I usually make the board a little bit bigger than what I need. And then I just use a hacksaw or some clippers, some metal tin snips or something, or even better be a bandsaw to cut it off. And then you want to file the edges down, cut the board to the final size with clippers. This is a hacksaw, not a jacksaw. Sorry about that. Hacksaw or bandsaw, and then file down the sharp edges. Drill the holes. This is a good drill that I got from the internet for like $500, and you can get one from Home Depot and Lowe's too. This one works well. Drill your holes. Be sure to use the correct size bit, because if you don't, first thing, the default sizes in EagleCAD are not going to be correct for this type of design. You're going to have to make your holes about I believe it was like 40 mils. It depends. You need to measure your drill bit that you're using. If you're using a 30 mil or a 40 mil drill bit, or whatever it is, then you need to make sure that your drill sizes in EagleCAD are that size. That means you're going to have to go to EagleCAD and you have to change every symbol drill size. Typically, is what that means. That's why you need to learn how to learn how to edit the libraries in EagleCAD. Mainly, the reason you want to do that is to get extra components, and so you can change all your drill sizes. Which means you have to edit every part number, which is really tedious. I wish there was a better way to do it. There is another way to do it, to change your drill sizes universally across the board, but it just doesn't work that well in EagleCAD. I mean, you can try it, but I didn't find it to work that well. So I just manually would go through each component and increase the drill size for all the pads. Okay, and that's it. Once you do that, then you just you populate the board, and your board is done. And that's how you're going to do the ping pong game. Now, alternatively, there's also the board shop option. This is a professionally designed board you see on the screen here from a Pentalogics, which is partnered up with EagleCAD and Newark as well. Newark is the good place to get your PCB boards. They have last time I checked, they had two different vendors. One was Pentalogics and another board shop. But typically, I mean, if you want one, you may be able to get it for $150 or $200. But if you can get 4 boards, I think you can get like 4 of these boards for like $200 or $300. Depends on the size of it. Depends on how many layers you have. But really saves you a lot of headache, and you get the silk screen and everything. So this board was designed in EagleCAD. So yeah, so one way you can do this is to go to the PCB quote button, and I'll show you that really quick in EagleCAD. So once you have your board, all you gotta do is click this button up here at the top that says PCB quote, and then get PCB quote, and it takes you directly to the website in element 14, which is the Newark. And then you can do PCB fabrication. So we want to select PCB fabrication. And they got the Sunstone, and they got Pentalogics. So I've used Pentalogics before. Sunstone is also is one that I've heard of. It's a good one. It says here 40 years experience. So I would say they're both good. Pentalogics, those guys they work well. They're quick. I mean, you get the board quick. They'll once you get the quote, once you purchase it through this website, then the guy will call you, and you just email them your Gerber files, and they'll build it. They'll let you know if they see any issues with your Gerbers. And one thing I do need to mention, if you do this option, which I forgot to put in the slides, is that you need to download this utility called GerbV, which is a Gerber file viewer. And I do have a tutorial on how to use that. I'll show you really quick. Gerbe, you want to make sure that your files look good. And here's the Gerbe utility. It's a Gerber file viewer. And so you can open up your files in here and just make sure that they look good. So let's see here. Let's go to print, and then let's see here. I'll give you an example board design that I worked on. Well, I can't really see the files right now. I don't know why I can't see the files. But I do have a tutorial on this. If you go to YouTube and do a search for Gerbe tutorial. Yeah, this is my video that I made. It's a Gerbe tutorial. So just go through that tutorial and watch that tutorial. So I'll just put here, watch Gerbe tutorial. There we go. And that's about it. So that's but for this project, we're probably not going to do the board shop option. We're just going to do the in-house project for now. But ultimately, we want to get to the place where we can design the professional boards, because you have a lot more options open up to you when you do that. You have 4 layers. You can do many layers, which is probably what you're going to need if you do anything more advanced. So thank you for watching, and I'll see you for the next video.